Hi, my name is Dylan Stinson, and in this video, I'm going to be comparing the TTR500 VNA against the Keysight E5063 VNA. Vector network analysis is one of the most accurate methods used to characterize the performance of RF and microwave components, but traditionally, it hasn't been the most cost-effective. You can easily spend $20,000 or $30,000 for a traditional benchtop VNA, and the costs just keep going up when you tack on accessories and options. The TTR500 Vector Network Analyzer seeks to revolutionize the industry by providing performance, accuracy, and reliability at a fraction of the cost of industry-leading benchtop alternatives. To prove it, we're going to put it to the test. In this video, we'll be placing the TTR500 up against the industry-leading Keysight E5063A. We'll be basing our comparison on a variety of VNA performance parameters, including S-parameter measurement equivalence. This tests the instrument's ability to measure the S parameters of a device and achieve similar results. Dynamic range. This is how deep or how much of a difference in maximum and minimum signal strength the VNA is capable of measuring for a given IF bandwidth and frequency range. Measurement drift. This is how much the measurement changes over time due to changes in the test system caused by heat, vibration, or instabilities. This is also a figure of merit for how well the instrument maintains its user calibration over time. And lastly, form factor, such as size, weight, and power. For this first test, we're going to be measuring a simple bandpass filter using the exact same test setup and two-port SOLT calibration procedure on both instruments. We'll make the necessary connections, adjust the settings on each instrument, calibrate, and take two separate measurements. We'll then save and export the results for comparison. First, on the E5063A, we set the start frequency to 100 kHz and stop frequency to 6 GHz. Then we set the number of points to 801 and output power level to -5 dBm. The IFBW was set to 300 kHz. These are what someone might consider typical measurement settings for characterizing a coaxial filter. Now with the Tektronix TTR500. Similar to before, we set the start frequency to 100 kHz, stop frequency to 6 GHz, number of points to 801, and the power level to -5 dBm. The IFBW was also set to 300 kHz. After applying the settings, to ensure consistency, the exact same full two-port SOLT calibration and port extension was performed on each instrument. To see how this was done, check out our two videos on calibrating the VNA and applying port extensions. Now that we've calibrated, we can take the measurement. Notice any similarities between interfaces? How about any differences? With its industry-standard naming conventions and simplified navigation, the TTR500 is designed to be recognizable by both experienced and novice VNA users. You can also see that much of the E5063A's display is taken up by control knobs and buttons, whereas the TTR500 has no display or knobs. Everything is controlled by the user's PC and can be displayed on any compatible monitor chosen by the user. Optimized for touch and mouse control, and when paired with a touch-sensitive monitor, the TTR500 allows operators and technicians to make setting adjustments by the simple touch of a finger or mouse click, all from the comfort of their PC. And similar to the E5063A, the TTR500 has LabVIEW driver support and is Skippy code compatible, allowing you to migrate existing test code. In terms of performance, we do have to give the Keysight instrument the edge when it comes to measurement speed. The E5063A is a faster instrument, but for many applications, including filter tuning, the TTR500 is more than fast enough. With the USB design of the TTR500, the data can be exported directly onto your PC, streamlining post-processing and analysis. In comparison, the Keysight instrument will typically require the use of a removable flash drive. Sometimes measurements take multiple attempts and iterations. The time spent retrieving a flash drive is precious time that could be better spent analyzing the result and getting on with your work. Here are the results in comparison between instruments. As you can see, the TTR500 is achieving strikingly similar results as the E5063A. For the sake of time, we're only showing the magnitude data, but similar results were obtained for the phase data. Many types of microwave components require the highest network analyzer dynamic range possible, and in many cases, dynamic range is the key factor in determining a VNA's measurement performance. For this second test, we're going to make it a bit more difficult. Instead of measuring a standard filter, we're going to be measuring a high dynamic range cavity filter. this filter will put any VNA's dynamic range capabilities to the test. Using an equivalent test setup and calibration, here are the results for both instruments. As you can see, the TTR 500 is achieving similar or better dynamic range compared to the E5063A, with its noise floor well below 120 dB. Also of note, in the passband, both traces are right on top of one another, indicating zero compromise to accuracy. Thanks to its high dynamic range, when it comes to characterizing the stop band insertion loss performance of high dynamic range filters and switches, or measuring path loss and isolation between antennas and components, the TTR 500 is right on par, allowing you to see as deep or deeper than some more expensive benchtop alternatives. When it comes to VNAs, drift errors are how much the measurement changes over time due to changes in the test system caused by heat, vibration, or instabilities. This test will serve as a figure of merit for how well the instrument maintains its user calibration over time in stable environments. This is important in many automated manufacturing applications where less drift means greater measurement stability and less time having to spend recalibrating your measurement system. For this test, we placed each instrument in a temperature-controlled chamber set to 23 degrees C. After stabilizing temperatures, the instruments were each calibrated using the same full 2-port SOLT calibration and setup to measure a 10 centimeter long low-loss coaxial cable. The full 2-port S parameters were saved immediately after calibration. Over the course of 90 hours, 2-port S parameter files were routinely saved to look for drift in the data. No changes were made to instrument settings during the tests. Here are the results for both instruments, looking at the change in dB of S21 versus frequency over the 90-hour period. As you can see, the TTR 500 has very similar results as the E5063A. While the ENA had nearly zero drift over the 90 hours, the TTR 500 had less than 1/10 of a dB of drift. Now it's up to you to decide if 1/10 of a dB is worth the added cost. Whether you plan to use the VNA in the lab, in the field, or on the manufacturing floor, you need to consider the size, weight, and power of the instrument. This test is an obvious one. With the two instruments side by side, we can easily see that the TTR 500 is a much smaller, more compact instrument. Consistent with other traditional benchtop VNAs, due to its size and weight, the E5063A will most often require a cart to move and share among groups. On the other hand, weighing only 3.5 pounds, a seventh the weight of the E5063A, the TTR 500 allows the user to easily transport, stack, and store the VNA, improving user access, uptime, and efficiency. If we fire up the two instruments, you'll notice a significant difference in the amount of sound created. Most of this is because the E5063A features a powerful and loud fan designed to help reduce the heat produced internally. By comparison, the TTR 500 is a very low power instrument, requiring no fan or external cooling. This means that you can have the VNA at your desk without disturbing your neighbors. And there's plenty of heat that needs to be dissipated. The Keysight E5063A has a rated power consumption of 120 watts, versus less than 16 watts for the TTR 500. If you include a typical 65-watt laptop, you're still only looking at 75 to 90 watts total, a potential cost saver for any engineering lab or manufacturing floor. So just to recap, in this video we compared S-parameter measurements, dynamic range, calibration stability, and form factor between the Tektronix TTR 500 and the Keysight E5063A. Hopefully from this video you can see that with the comparable performance, the TTR 500 is a very cost-effective solution.
Find out more at Vicom's website.